interruption. I don't know what happened to my this screen recorder. It's not performing well. So I was talking about that we are given these two numbers, right, star and gold, and we're having these two number. We'll be doing this all these two number, and what does benefit is going to give us? The number which is form, which we get after doing the zero of the star and the gold is such that every position of that number is such that imagine, let's again take that same example. We for the 10 we were having this, we were having 10, and for the goal we're having as 7. Converting this into the form of it is 1 0 1 0, it's 1 1 1, right? So what I'm saying that let us do the XOR of these two number. When we'll do the XOR of these two number, when we'll do the XOR of these two number, we'll get what? We'll get this number, this position, and this position has different bit is gonna become one. This position and this position has second position of 7, second position of 10 has same number, is gonna re is it will be 0. The third position of 7 and 10 have different bits, it's going to get 1. And let's look, and the fourth position of 10 and 7 has different bits, it's gonna become 1. What does that give? For every position of the number we got, this number we can call it as x, that is nothing but sort of 10 in 7, right? So for every location, for every position, that defines that in that position of the start of the goal, there are different bit, there is different bit if it's 1, and there is same bit if there is 0, as in this case. And there is different bit, there is 1 if at that position of both the bits of the star and the goal have different bits. So what we can do, we can simply do the XOR of the star and goal. We can count the number of set bits. Set bits are nothing but one, the bit which is 1. So we can simply the XOR of the star and goal, we can and count the number of, we can count the number of 1. And we can simply count the number of we can simply count the number of set pairs. It's pretty simple. Doing the XOR, and we can denote it by x. Doing the XOR of start and goal, right? Doing the XOR of the start and the goal, we got a number, and to that number we are simply supposed to do a while loop. We can simply do a while loop. We can check that while this x is greater than 0, we will keep counting its every bit. So we can simply check that. We can, like, it's pretty simple, right? We can convert this actually into the form of the binary, and then we can count the number of the ones, and we can convert. It's very simple how to convert the number from the binary. We're supposed to do x before, in order to check the number current bit is set or not. We can simply do a count plus equal to that will that current bit. We can check by doing x mod 2. If it's 1, that means it's set bit. If it's 0, then it's only just a 0 bit. And we can simply do then x divided by 2. It's that simple. So let's look toward the code. I've done the similar thing here, you know, taking the, taking the bit of start and taking the sort of the start and goal, initializing count with 0. If the current bit is 1, we're adding 1. If its current bit is 0, we're adding 0. And we are simply dividing it by 2. And we're in the count, and let's submit the question. Solution, and we see 100% speed. And like we are beating 93%. I hope you guys like